Hello all, so in this video we will solve a problem related to shear force and bending moment for a cantilever beam. So here the question is given as a cantilever beam of length 8 meters carries 2 point loads of 4 kN and 6 kN which are at a distance of 2 meters and 4 meters from the left end respectively. So first of all let's try to draw the cantilever beam. So we all know that a cantilever beam is that whose one end is fixed and the other end is free. So first 4 kilonewton is acting at a distance of 2 meters from the left support, means from A. So this is 4 kilonewton which is acting at a distance of 2 meters, and 6 kilonewton is acting at a distance of 4 meters from left end. So from A till 6 kilonewton it is how much? 4 meters. Already this is 2 meters, so obviously this remaining distance will be 2 meters, because from A to 6 kilonewton it is 4. Okay, next draw what is the total span? 8 meters, so obviously this remaining distance would be 4 meters. Okay, now we need to calculate the shear force and bending moment. So we all know that at A we will have a reaction, and now first we will calculate the reaction. So RA minus total downward load is minus 4 minus 6 equal to 0. So from here we can write as RA is equal to 10 kilonewton. Okay, now we will calculate the shear force. So we will start off shear force from point B. So shear force at B is equal to 0 because there is no load acting on the point B. So it's a free end, so there is no load also, and hence shear force is 0. Next we will mark these points. Let me take this as C and let me take this as D. Next we will calculate shear force at D. Shear force at D will be equal to, now I am calculating shear force at D, so I will stand at this point. So to my right side, what is there? 6 kilonewton acting downwards. We know that right side upward is negative, means right side downward is positive. So this is plus 6 kilonewton. Next we will calculate shear force at C. So when I am calculating shear force at C, I will stand at this point. What is to my right side? I have two forces which are acting downward. So right side downward is positive. So it is 6 plus 4, which is 10 kilonewton. Even if you have a doubt, you can see. If you see left side also, there is only one force which is acting upward, which is RA, which is 10 kilonewton. According to our sign convention, left side upward is positive. So like that also it is correct. So what is shear force at A? Shear force at A is the load acting at A, which is plus 10 kilonewton. Okay, so this is how the shear force is. Now what we will do is we will calculate the bending moment. So let's start. Bending moment at B. Bending moment at B is 0. Why? Because there is no load acting on it. It's a free support also. So in both the cases bending moment is 0. Now we will calculate bending moment at D. So if you see, even though there is load acting on D, we are calculating bending moment on D itself. So it is 6 into 0. There is no perpendicular distance because we are standing on D itself. So bending moment on D is also 0. Next we will calculate bending moment at C. So when you're calculating bending moment at C, imagine you are standing on the point C. So what is towards the right of your C? D. And 6 kilonewton is acting downward, so it will hog your beam. So it is minus 6 into 2. So it is minus 12 kilonewton meter. Next we have bending moment at A. So what is towards the right side of A? 6 kilonewton, which is doing hogging bending moment, and distance from 6 kilonewton to A is 4. So it is minus 6 into 4. And similarly 4 kilonewton also is pressing your beam downward, so it's hogging bending moment, so minus 4 into 2. So it is minus 6 into 4 minus 4 into 2. So how much is the answer? It's minus 24 minus 8. So it is minus 32 kilonewton meter. Now we will sketch the shear force and bending moment diagram. So let's drop the lines. So we will do the shear force diagram first. So we will draw the shear force diagram. So we can see all the, for cantilever, almost all the shear forces will be positive only. So this is B, this is D, this is C, and this is A. So if you see here, what is shear force at A? It is plus 10. Correct. So this is 10 kilonewton, and I am drawing SFD, and up to point C the shear force was 10 only. Correct. Then what is at C? 4 kilonewton is there, and 4 kilonewton you drop it. So what is the shear force at D? 6. So shear force at D is 6. And what is the shear force at B? 0. So from here to here you put a join. So this is plus, and what is this value? this value is 6 kilonewton. This value is also 6 kilonewton. This is also plus, this is also plus. So this remaining value would be obviously 4. Okay, 6 plus 4 is 10. So like this you draw the shear force diagram. Now what we will do is we will draw the bending moment diagram. So for bending moment diagram, it's quite simple. So for cantilever, the bending moment diagram will be negative. So A, C, D and B. What is the bending moment at A? It is minus 32. So go down. This, let's say this is minus 32. I'll write it as 32 kilonewton meter. Next, what is the bending moment at C? Bending moment at C is minus 12. So let's say minus 12 is somewhere here. What is bending moment at D? 0. And these are point loads, so you have to join them straight. So let's say 12 is here. So this is how your bending moment diagram looks for cantilever. Okay, I mean for this case. And here you can see from D to B there is no loading, so there will be no bending moment. So what is this value? What is the bending moment at C? 12. And bending moment at A is 32. And this is minus. Since there is no loading, the bending moment is not occurring. Okay, so this is how you need to solve problem related to cantilever beam carrying 2 point loads. So hope all of you understood the video. Thanks for watching.